How do I get rid of the AI button? Huh. Hey, welcome to Coffee Compiler Club. Here today to talk about compilers and language runtimes and garbage collections or forth interpreters or anything else. I have a couple new people. I'm going to ask the new people, give me a 10-second intro. I'll call you out here. Everyone's being recorded. You're all going to be up on YouTube within a couple hours generally. That's the end of my spiel. Amit, you were here first, so I'm going to start with you. Why are you here?
Yeah, so hi, I am Amit, and I just graduated in July 2022, and I am working on Hotspot and basically in OpenJDK on Hotspot and managing the S390 export actually. And I am interested in C++ and graph algorithms and compilers and interpreters. So I recently was working on one of the C2 change. And then, as I mentioned, I came to know about one of your research paper and then I came to know about this coffee compiler talk. So I thought I would give it a try and yeah.
Okay, sounds good. And then Steve?
Hey, everybody. I actually have joined quite a while ago, but have just been caught up with work, especially on the time that the video stream is active. So I apologize for not being here very often. But I finally carved out some time today. To give you some background, I'm the co-founder and CEO of a company called Ellipso, and we focus on WebAssembly tooling, kind of trying to create a new virtualization layer inside your application to actually run user code safely in an isolated sandbox using Wasm. And so we create a bunch of tools to do this. And I'm here in particular to share and see if there's some interest in helping on a new WebAssembly runtime called Chicory that's native to the JVM. I've mentioned this a couple times in the CCC Discord, but there's some interesting things happening with the runtime. And in particular, I have kind of a question that's maybe a little bit out there for some of the real deep compiler experts here. So maybe in the open floor section, I can.
Well, we're at the open floor section, so fire away.
Okay, cool. Well, I'll toss a link to the GitHub repo. Basically, we have it started as an interpreter, as many good compiler projects do, I guess. And this actually will run Wasm code natively inside JVM without having to do any kind of FFI to some kind of external runtime. And over time, we added an AOT pass to actually translate in real time the Wasm instructions into JVM bytecode. And it uses a project which folks here may be familiar with called ASM from I think Red Hat and some other folks work on this.
There's an old project called ASM for doing.
Yes, it's an old project.
Okay, fine.
Yeah, but it just generates JVM bytecode kind of on the fly.
Right.
And so out of curiosity, I'm thinking it could be interesting to let the JVM run some optimization on the translated Wasm to JVM bytecode, and then reverse that back to Wasm to do a optimization pass to then let the Wasm run in other runtimes in an optimized way. So instead of using something like an LLVM kind of optimizer, is it possible to take the sped up Java bytecode and reverse back to Wasm? Or is by the time it's optimizing, are we already in like native code?
You do native code. It goes from bytecodes to native in one step.
I see.
Now, Hotspot's a portable backend compiler. If you want to write a Wasm backend, you got a Wasm to JVM to Wasm to JVM to Wasm. I don't know if you're gonna get any gains somewhere.
Okay, I see.
But
so Hotspot we could target Hotspot,
yeah,
and then Hotspot could have another backend that goes to Wasm.
Right, get Hotspot to target Wasm.
Yes, get Hotspot, right.
And again, if you have a Hotspot to Wasm target, I am sure there are people who would like to run Java stuff in the browser that would think that was an interesting piece of technology.
Definitely.
There's definitely, whatever, fine. Yeah, Hotspot's been ported 12 times, 24 times.
Okay, that's interesting. I didn't realize Hotspot, you could then take Hotspot and target something else.
You need some Hotspot building engineers to, work out the details of, but like I said, porting, it's been ported 24 times.
Cool. I will
Is
check that.
Amit that engineer that you need?
Maybe. You're interested in this kind of stuff, huh?
Yeah.
Yeah, I'm looking at the repo now.
Well, feel free to join and reach out on Zulip. We have a pretty active group there that commits and works on this thing. Lots of folks from our team and from Red Hat and a couple other places are contributing. So the more the merrier. And if you have ideas on how to kind of make Wasm more approachable for JVM folks, we'd love to work with you.
So the other piece of that is C2 is a faster version of LLVM, so you're not going to get anything more out of it than you're going to get out of LLVM.
Right.
I mean, it doesn't do everything LLVM does, but it does it a whole lot faster. So, hard for me to judge the generated code that comes out would be better or worse.
Yeah.
And where you're starting from.
Yeah. We don't have a use case really for this yet. It's kind of more of just like, nerd snipe curiosity.
Well, that's right. Exactly. That's what I'm hearing, but fine. Maybe, maybe.
Hey, a lot of good things come from this. So
Yeah. If you read up a hotspot in like a server mode and he class for name Wasm files from somewhere or class files that you put in, then you had to run them to get them JITted. I guess that's the trick. So I'm about to say server mode, but that wouldn't work. You actually have to run them to get them JITted.
Right. Yeah.
How about Wasm to bytecodes? Wasm to bytecodes.
Yeah, he has to generate bytecodes, run the bytecodes as intended in order to get profiling. Then you'll get compiled versions with inlining and unrolling and all kinds of crap, but also all range checks thrown in and stuff that, the Wasm translation back.
But it has to translate Wasm properly.
And then right. So he has to produce C2 producing Wasm bytecode. Wasm out means that something has to run it. So this is C2 Java in the browser running in the browser and spitting out Wasm to be executed by the native Wasm hardware that it thinks it's on. Right. This is definitely a nerd snipe game. And then you're capturing those because you're trying to forward them to some other backend, some other Wasm target.
Yeah, exactly.
Yeah, that's an interesting challenges there.
Yeah.
And kind of
I figured there's so much great work has gone into him and the hotspot. Like maybe there's a speed up here for some Wasm code.
I couldn't tell you. Yeah. He does. I mean, C2 does kind of heavily depend on the profile data. So it's not like you could just go ask like the LLVM, just go ask it to go compile this. You won't necessarily get a good answer.
Right.
Wild. Fine.
I'm not sure how you would do the throwback to the interpreter in Wasm.
You'd have to,
you can't exactly just segfault and catch the segfault and go, oh, I need to go back to the interpreter now.
You port hotspot to Wasm, not C2, not just C2, but hotspot. That includes the interpreter, right? So you get the whole stack. Now, the other parts of the stack that say I have OS calls to libraries and native code and crap, they probably port really easily, but they're big, so there's a ton of it. So you got a lot of work, but they should all just be plug and play to some existing infrastructure. The interpreter isn't too bad. I guess it's as hard as the compiler. Neither one of them are terrible, but they're not small. I've done the interpreter port, like I said, a bunch of times. For me personally, 4 or 5 times for both. It's not terrible. Your first.
I mean, a lot of those stubs are going to be pretty short to write because it's going to be like you tried to access the serial port, you crash the whole program because that's not a thing in the browser.
Although none of the stubs say go to the serial port. What are you talking about?
Well, so let me clarify, because we actually don't really care much about running in the browser. This is like, we want to run Wasm in the JVM, and that's what Chicory is for. So I can load a Wasm module, execute it. We're talking about like, can I run it through Hotspot, compile to native, do the optimizations, and then somehow take the optimized code and reverse it back to Wasm.
When you get optimized code,
you can run and Go, you can run anywhere, but just like benefiting from JVM.
What you get out though is optimized for the target backend.
Right.
Yeah. So.
Yeah. Cool.
Spit out RISC-V if you wanted to have a RISC-V interpreter as a.
You're saying there's a chance.
Oh, okay. Well, that was an unusual start to morning. That sounds good. Somebody had mentioned fourth. We want to do a fourth go around. Aaron, you were curious about fourth.
Yeah, I was talking about fourth and specifically the sort of deep integration with native things. I was thinking about, so I was at Google for a while and saw some of the way the YouTube code base was run. And, 99% of the code in the YouTube code base is Python. And 99% of the cycles that YouTube runs are C++.
Sure.
Because they use very small, here's a tiny piece of C++ that does this key piece of like video transcoding, whatever, or machine learning, kernel, linear algebra things.
Busy looking for cats in my videos. Yes.
And then you've got a bunch of Python that orchestrates everything around that and figures out what to do and calls into that stuff.
Right.
And it reminded me of the way people did early fourth code, where you didn't spend most of your time in fourth in the like fourth interpreter lookup thing. Your fourth was building up collections of assembly and then calling into the blobs of assembly that you had built up. And when I listen to people who build APL interpreters, like the way the APL interpreters tend to work is that most of APL interprets very, very slowly, except that it's got a bunch of patterns in the interpreter that says, if you recognize this thing, that's a matrix multiply. Go to the super optimized matrix multiply code. What is that right level of abstraction for pulling out a piece of work? Because to some extent that, the JVM is very much in the weeds compiling, I'm going to unroll your loops for you. And Python is, I'm going to take this matrix multiply and replace it with an optimized matrix multiply.
Right. So I'd have said that fourth is the language itself like encourages and demands that you basically write fourth, which translates one-to-one to an assembly. Not quite, but it's close. But you're writing fourth, so it kind of feels high-level languagey, and at the same time, you're writing a machine code instruction when you write some fourth bits. So the game where you move from fourth to assembly is a lot more fine-grained or something. You can go back and forth pretty obviously, but it doesn't do any optimizations to speak of. And it's not really geared for optimizations at the assembly in the weeds level of loop unrolling, yada, yada. It's geared for, high level replacement. What you generate code for is you first ask the question, what do I have? And then I'm going to generate code this way or that way. So you get every fourth program as a DSL of its own kind.
So what constructs fourth supports?
Well, yeah. So this is like a stupid thing that I think every compiler person who's gotten up to somewhere close to student level should go do a fourth interpreter. It takes about a week to get a productive one and write a game in it, and you'll understand everything there is to know. This is not a hard problem. So there is a parser. It is strictly white space delimited, nothing else but white space. So all your operators can be mangled inside of all your other things. It's part of the go make a DSL, you can throw operator syntax in with other keywords. They're all just, if it's not a space, it doesn't count. Once you've parsed a token out, you look it up in a hash table. And if you missed, you're errored. If you're only digits, you got a number and you push it on the fourth stack. And if it's not, then you find it in the hash table and you execute it. That's the REPL, all of it. It's the whole REPL. Okay. The place where you start to do the code gen things is there is a keyword called colon that you look it up like normal, you type it in the REPL, you look it up like normal, and he runs through, then he asks the same parser for the next token. And he, takes over the token parser and grabs a token. That's the name of the function you're about to define. So colon space, some name, you're just defining a function. It can have every operator character you want in it. Doesn't matter as long as it's not white space. Then he's still taking over the parser. He grabs tokens and does the lookup. And if he misses, it's an error and a compiler error now. And if he hits a number, he puts code to push it. And if he finds a token, he puts code to call it. And that's, basically the compilation in a nutshell. Now, there's a few other tricks. Words in the fourth language would be functions. Anywhere else have a bit that says whether or not they should be executed at compile time or not. And that would be all your control flow thingies. So you write colon fact because you're writing factorial, and you come in, you know you're gonna have a number on the stack. So maybe you've put in a comment in the code. Well, that's a token. He looks up, he skips to the end of comment. Okay, fine, whatever. But the comment parser itself is an immediate word, it's called. And the tokenizer doing code gen stops and just runs at the guy, the comment guy. He sucks it up to finds the end of comment. Then you're going to do something like, hey, I need to check this thing for null. So you write dupe and less than, and the dupe is because I need 2, and then it's a stack. So the less than eats it, puts a Boolean back. Now you write an if. Well, the if needs to generate some code of a future target in the code stream that hasn't happened yet. So the if's an immediate guy, and he puts a test in the code. He generates code in line, and then he saves some pointer to the end of the world that you're going to jump to, and you're going to patch in a minute. Then he goes back to the name compile parser, which is just reading a token, and if it's immediate, run it. If it's not immediate, call it, whatever. So sorry, another guy per show. So it's like this really trivial thing, and because the options are your number, you push it, you're an immediate, you do it during compile time, or otherwise you're something, you just do it immediately. It's super trivial. You understand all of it. But then things you put in, they generate a call every time, and the optimizations are really limited to inline tiny calls. So variable references, which would be function calls to go get a variables, getters and setters, are commonly inlined. Stack operations are commonly inlined.
Yeah, what was
Sometimes people
that
get clever.
about? That is a stack-oriented language. Or
Yeah, it's a
something?
stack-oriented, it's an untyped stack-oriented language. Yeah. Like I said, this whole thing that I just described in 5 minutes or less can be done in a day.
So I
or
would
two.
have a different word that was add integer and add float.
Yeah, so it's untyped. So you need a different word there. If you've put a float on the stack and then you call the integer add, well, he just takes the bits. You did, Java, you'd call it double to raw bits, right? Or raw to double bits, whatever. You got a bunch of bits.
Yeah.
And that's, the strength and the weakness. You can pointer mangle, you can have bits on pointers and no one cares. And the hardware will catch you if you've screwed up your pointers and crash and burn. It's just your process going down, the rest of the system saved by the OS. These
So
things
very
are
powerful,
often
but very
used for
dangerous.
startup of new
Still
chips.
seems like it's easier to write than assembly.
Oh, it definitely is. Yeah, it definitely is. And like I said, it's very close to your writing assembly directly. You typically know on all the common words what the assembly that's going to get generated directly is. It's just going to come out as you'd expect. When you get into a little bit of inlining, you get a little mishmash of things. It's not quite so direct, but there's never a lot of optimization going on here. So it's really, it's a tiny optimized C compiler with a lot less syntax than C, if you will.
So
And
how
it's
do you
all done
build
in
up to
REPL.
bigger things? If you wanted to write, say, the TCP stack in
Yeah,
Forth.
yeah. So this is for startup of tiny new chips. Somebody makes a new chip, they have to have a back end. They want to have an interactive experience. They don't want to just compile C and run it on the chip and see what happens. You spend a day or two writing a Forth. You peek and poke all the hardware registers directly. You crash and burn the chip all the time while you're in the REPL to sort out what the chip's actually doing as opposed to what it was spec'd to do. I don't know. As far as I know, it was still being used for startup of small chips, even 5 or 10 years ago. And then I haven't seen one since then, but would make sense.
I mean, from what I hear, it's mostly used today in like cars and satellites and super memory constrained environments where the whole program should fit in the microcode section of the chip.
Yeah, I mean, if you're going to send a tiny ass chip up into space and you can't get at it and you want to have some way to run generic code, you fucking run a shell script? No, you run a Forth interpreter. Yeah, totally. So I have no idea if NASA uses it, but yeah, that's an ideal test case for it, or use case for it. First learning languages. I would claim that if I was teaching programming to undergrads, that somewhere early on in life, second year, not even third, I'd make them write a Forth interpreter in assembly followed by write a game in their fourth interpreter. And they'd see the step up. You also see all the meta issues. I'm generating this to generate that. You can do self-hosting in a fourth interpreter in, a page that fits on your screen. You can self-host. So
Yeah, the
porting an
CPU
existing
class at Georgia Tech used to teach fourth, but by the time I got there, they had switched to just C.
Yeah, I can get it, but the whole meta level of I'm generating code, I'm writing code to generate code to write code to generate code comes across strong in fourth and not so in C. There's a clear distinction. Now you get better code out of C, you get a pipes, you get a higher level of this and that's a lot of good things, but you miss the whole meta interaction level.
Yeah, I mean, I thought there was a lot of real power in. So the way that class used to be organized, which I can only vaguely do because I didn't actually take the class at the time, was you would get an Intel chip that had a bunch of registers in it that you couldn't normally see, and you started in ring -3.
Okay.
And your goal was to write this little fourth interpreter that generated instructions, and you were trying to like find all of the instructions that were valid in all of the different instruction formats. And you'd say, here are the various formats.
Yeah.
Go try everything and see if it reboots.
Yeah, that's a good job for
you would write this fourth interpreter and you'd let it run for a little while, and then it would print out the instructions that it had discovered and mapped and built out, and suddenly you would learn a lot about the way the Intel chips work by just discovering what all the instructions were.
Yeah, totally. Back in the day, my first full job was Z80, and then there are extra registers at the edges of the die that were new and the die wasn't uniformly ready. So you could ask a question at startup, hey, do these instructions work? And if they did, you got them. And as they improved their process, they always worked. But the first chips didn't, so they were not official for quite a while. Fine.
Whereas in C, like there was no good way in C to do the class of your first project is discover the assembly language, knowing a few of the well-documented pieces of the assembly. Yeah. See, or not even the assembly, discover the machine code instruction format by saying, here's a bunch of instructions that are well-documented. Go find the ones that aren't documented.
You could imagine, writing the code into a buffer and then jumping to the buffer and executing it. But the thing with C is that he assumes a stack, and he assumes a stack in stack pointer register, and he assumes standard calling convention, and none of that's true in fourth. He assumes a stack, but he didn't know shit about it. And you can implement it. And as part of porting to fourth, you implement the stack in fourth. So it's like, So as soon as you said, hey, I want to do the stack part of the registers.
The stack is a user space concept in fourth.
Yeah. Yes, absolutely. It's the calling convention, but it's actually fully user space. Yeah. Fine. We are well down into strange weeds today. All right, Zalim. You got a mic working? I'm going to ask you to intro yourself.
He does. He did. He introduced himself.
Yeah. Actually, I already did a couple weeks ago. I can repeat if someone don't remember.
Go ahead.
Did you come here before? Oh, there you are. Yes, you're not.
Yeah,
I haven't seen you in a while. Cool.
Yeah. So I'm working on Kotlin at JetBrains, specifically working on compiling Kotlin to WebAssembly. Yeah, basically that's it.
Kotlin to WebAssembly. Okay, fine. No relation to Steve here, right?
I know.
We each we know each other. Yeah.
All right.
Small group of us.
WebAssembly day.
Is your goal to run Kotlin in the browser, or more ambitious than that?
Everywhere where you have WebAssembly, basically. Yeah, so we're working on two main group of cases. Like first is running inside the browser for building applications, and also we working on running outside of browser as well, specifically for running on server side for kind of serverless Lambda things. Yeah, I think it's best use case where you can get the best from combining Kotlin and WebAssembly.
Like
one cool thing about Kotlin and the work Zalim does is it's really pushing the boundaries on the Wasm GC spec in order to get Kotlin and eventually maybe Java. You definitely need to get the GC and rich types and structs and all these kinds of things into Wasm. So appreciate the work you're doing and excited to see the progress.
Thank you.
I was wondering about that. So you're relying on some kind of GC abstraction inside of the Wasm spec to run Kotlin. So without it, doesn't work.
That's right.
I see.
Yeah, that's right. This GC proposal, what was finalized last year, and it's available in Chrome and Firefox. It's available under flag in Safari, not in released versions of Safari, I think, so far. There is some nice progress outside of browser. There is pure WebAssembly virtual machines like Wasm Edge, which support GC proposal and exception handling proposals. There is support in Whammer virtual machine, Wasm Time virtual machine, also working on Wasm GC support.
So that was the thing I hadn't understood about Wasm for a long time. So ARM and x86 don't have garbage collectors as part of their assembly languages. Why does WebAssembly need a garbage collector when x86 and ARM don't have a garbage collector? You'd think that it would just give you the constructs of give me a large blob of memory or I'm giving back a large blob of memory.
Garbage collectors tackle languages at a different angle. They hit them at a different angle than all the usual codegen sides. Garbage collectors crawl all your living space. They crawl your stacks. You talk about Forth having a visible stack. All stacks are visible to the garbage collector. They're not typically visible to the language from inside of itself.
Well, speaking about WebAssembly, you need to either provide high-level primitives for GC languages, or you need to provide low-level primitives to effectively implement GC things. So in case of WebAssembly, community just decided to provide first thing, high-level capabilities, because without Wasm GC proposal, it's tricky to implement own garbage collector effectively. You can't access to a stack. You can't walk through stack. You can't. Before we get thread proposal, you also can't implement concurrent GC.
You want a concurrent GC too. Yeah. These are all tough things to just get internally in the language, in a language, as opposed to in assembly, where you totally know how the language is implemented. I think the goal of Wasm is you don't know how the implementation goes.
Well, that's my question. Why doesn't it go the other way? You could have a Wasm that just doesn't give you a stack. If the only thing Wasm gave you was allocate me a block of memory and give back a block of memory, and it was the responsibility of the language that was being compiled to Wasm to have a stack.
Yeah. One important thing about WebAssembly is safety. Community try to keep it good to guarantee safety. What you can verify properties, what you define. So with GC proposal, for example, you have typed structures. So you can't randomly access to memory, corrupt something, or change something, reinterpret some part of memory. So yeah, that's a reason why we have high-level primitives to provide on top of it additional verifications, additional guarantee.
So does WebAssembly have a notion of a call, subroutine call and return? Function call?
Yeah, various different kind of calls. There's static calls, there's indirect calls through a special table with references, and with GC proposal, we also get ability to call. We can have just reference to some function on the stack or in some locals, so you can call by ref.
Right, but there's a stack. As soon as you said there's a call, there's a stack. So
Yeah.
Wasm implies the existence of a stack.
Yeah.
Right, and that implies.
But with some restrictions.
Sure, because like on the really old systems I've worked on, if there's no recursion, there's no need for a stack. Your stack frame was just a little permanently allocated set aside piece of memory that was with the code, including return address, which, like I said, is no recursion. So you only ever had one return active at a time. So that was just stored in memory somewhere, and you didn't need a stack.
I was thinking of the like MIPS chips that had jump and link, and it put the instruction pointer into the return register. You had a stack if you stored it, and you didn't have a stack if you didn't store it.
Yeah, even RISC-V has jump and link. It's a very old, very easy way to do something with that. And right, exactly. And if you don't store it, you don't have a stack, and if you don't need it, if you're a leaf function, you never store it. It's just sitting in the register, and you jump back to it. So, but all I'm just saying there is, hey, you got a call. Okay, now you got a stack. As soon as you got a stack, you have to crawl a stack for GC. Then you have to have special instructions to go find and crawl a stack for GC. And that gets complicated. And now it totally makes sense to me that you have a separate spec that says this Wasm box is GC'd and that one over there is not, or uses a different GC or whatever. There's no requirement that it be the same. Otherwise, you have to have all this self-reflective stuff that's also safe to go crawl your own stack. And I think that's kind of a bitch. And then
but it's that you want to do more safety than just process isolation. You could totally have a Wasm space that was just like,
well, suppose
I'm going to make some memory and stuff. But if your goal is to really have strong types inside of the VM,
you want to do concurrent GC on your Wasm space, and you treat your Wasm space as a completely open assembly box. And the call instruction just does like a jump and link. It has no notion of stack pointer, and you can edit the stack pointer and whatever you want. Like suppose you do that model.
It just makes it feel like Wasm is pushing down toward assembly from JavaScript, not pushing up from let's design an assembly and just make it portable.
Yeah, because you're keeping the notion of a stack that you want to have some safety around, which, honestly, maybe you just don't. Just blow yourself up. So one of the things here about the GC proposal also is that if you want a GC, you ask for it at the Wasm container you popped up. And if you wanted to have otherwise you'd have to somehow link into your project, your Wasm project, the GC. And that seems like you're biting a big chunk of extra API space. I make a GC for Wasm because I'm a cool guy and I like writing concurrent GCs. Zarin makes his own GC version, and Aaron, has a cheap ass dumb GC because you just want the damn thing to work, and whatever, right? Suddenly now the GC market has 5, 10, 15 GCs. They all have incompatible ways in which they handle pointers and what they allow and what they don't, and their performance trade-offs, whatever. And I don't know. I can kind of see not going there.
Yeah, I think that's one of the really important pieces of having the spec define it, because like right now, if you have, some Wasm compiled from Go, it also includes Go's scheduler, runtime, garbage collector. You have some compiled from another language that has garbage collection. It's bringing the GC into the Wasm module with it. And that's like, okay, if you can stomach the size of the module and potentially some pure performance hit. But it gets really tricky when you're linking modules together that are written in different languages in source, and so like share memory from Go down to Rust across to C in all of their calling conventions, their runtimes, etc. And so having it spec'd out and being like, here's a consistent view of all the ways we lay out memory, all the ways we address access memory and stuff like that is just like, it's going to save us a lot of headache if it all.
Because you want Wasm modules written in independent garbage collected languages to still be able to pass objects around to each other.
Correct. Yeah.
Right. That makes a lot of sense.
Yeah.
I've certainly felt that Twitter had JavaScript and Java in the Twitter app and did a lot of work in web views in JavaScript and did a lot of work in Java. Essentially, all of our crashes was in passing objects between garbage collected runtimes.
The only place I ever saw that work was you serialized it to an array of bytes and then deserialized on the other side.
That was
But that's performance.
I'm going to say.
It is.
If I have to serialize a tweet and pass it across and deserialize it on the other side, fine. If I'm writing spaces and I'm doing real-time audio channels, I really don't want to serialize all of the audio to a hexadecimal string and then deserialize it on the other side because I'm sending the audio packets between Java and JavaScript as JSON.
But in the app, would you risk it to crash? So which one is better?
Did you ever try Twitter Spaces?
No.
No.
They definitely chose crash.
Oh, well.
Excellent.
Excellent strategy, yeah.
And you're not working on that project anymore, I take it. All right. What else?
But yeah, that team, everyone on the team was convinced that they either needed that piece of the app to be entirely in Java or entirely in JavaScript and not span the boundary.
Right.
The problem was that half the team wanted to go entirely one way, half the team wanted to go entirely the other way.
Put them in a small room with knives and let the survivors, pick it.
Honestly, should have just flipped a coin and had everyone agree to abide by it.
Right. Yeah, there does come a point where
is it JavaScript?
Is
it JavaScript run inside JVM?
Sorry, I talked over somebody. I didn't hear the question. Ask again.
So Spaces was doing all of the communication between the different people who are in the same space using WebRTC inside of a web view component inside of a Java app. The microphone was controlled by the Java. So you would record some audio from the microphone in Java and then hand it to JavaScript, who would then do WebRTC to get it to the other people who are in the room, who would then receive the audio over WebRTC, which they would then hand back to Java to actually play as audio to the speakers.
So it's JavaScript run in some native virtual machine and Java virtual machine and JavaScript virtual machine somehow communicate here.
Right.
Passing.
So as far as the JavaScript was concerned, it was calling out to native code from a web component. And as far as the Java was concerned, it was calling out to native code from a Java component. Except that while both sides thought they were talking to C, they were each talking to a garbage collected language with a moving garbage collector.
Right. Two moving garbage collectors. Java would normally hand you a handle and tell you not to touch but the C is known to peek through it, the handle, and then especially for shit like that. Yeah, so what did you do with that? I mean, how did you tell them not to move them? There had to be some way to pin the data or something.
Oh, well, so you can convince Java to not move things. You can't really convince JavaScript not to move things. So I believe they eventually resolved it with a rule that said, only ever allocate anything in Java.
Right.
So every time the JavaScript needed to allocate one of these buffers, it had to call Java and be like, buffer, please. And then it would fill the buffer and then it would hand it back.
Sure. All right, fine. Well,
so we essentially wrote a malloc in the middle of our JavaScript web view.
Gotcha. Right.
Not recommending this.
Not
excellent strategy. Again,
like,
excellent strategy.
You could object pool. Yeah, excellent sausage making.
Anyway, my point is that would have gone way better if both systems had been built on top of a shared garbage collector abstraction, and it was doing all the garbage collection once neither side was holding a pointer to that buffer. It would be a lot easier to have a shared buffer being passed back and forth between two different garbage collected languages.
Is that Hotspot's gone through a dozen garbage collection strategies over the years. So it continuously has churned new and better garbage collections. And
how it maintain one framework for garbage collection?
How did it maintain what?
One framework, one approach. So to different approach of garbage collection, but
it didn't start with one framework. It started with somebody hacked the first GC in, and then somebody hacked that one to be generational, and somebody hacked another GC in, and it was different. And there were pound if defs, and then the generational guy got parallel old gen and was the default collector and was super fast, and the new guy was 3 different things and 4 different things, and then people wanted a concurrent, but the old school parallel collector that worked for 10 years was never going to be concurrent. And eventually there was the massive screaming and yelling and gnashing of teeth that turned into a GC-like API that everyone could call to that would do these things. At this point, Hotspot was not very well suited to having sort of multiple GCs. Like there's
but the bytecode kept working.
Old gen, and then the class space for perm gen, and then there was a bunch of buffers allocated for NIO and IO, and then you wanted to have pinning of some of these and not pinning of the others, and fingers were everywhere throughout the VM that everyone had to do things with. Like the VM internally talks to Java heap objects all the time as raw C pointer values. And if the collector moves it while the C is talking to it, well, the C just, does the wrong thing. It crashes. So you had to have some way to say, quit talking to these things directly, except at the end, you had to talk to them directly. So instead you had to say, and here we lock out GC while we do some things. And so a bunch of these things sort of grew up slowly over time and then got hacked hugely to finally settle out. So I think it's now well settled and you can switch GCs without too much grief. It has this huge API surface area. And if you were to design a GC from scratch, you could certainly have a much smaller surface area on your API.
So they share API something, or they're all over the place and somehow talk to each other?
Mostly kind of share the API. Like there's a piece of that API that goes into C2. C2 generates read and write barriers. And some of them are empty on some GCs and not on others. Some of them can be optimized or not, depending on a bunch of criteria. So some poor GC guy is busy trying to hack C2 and has no clue how C2 works to try and teach it, when he can say, hey, this Brooks style barrier, I loaded up a thing, I don't have to do the second load because I know, because something cheap's going on here and I can just get rid of the extra indirection layer, on a read barrier, whatever it's going to be. I don't. So I'm just saying the API is big and thick. There's a separate one for C1, for C2, and the interpreter, and then the VM had a barrier, but that's not counting all of the different spaces and their own constraints. I'm doing class loading. Can I do a GC cycle in the middle of class loading? Well, there are places where I cannot, because you can't touch your perm gen while I'm trying to do class loading. And C2 comes along and says, hey, I got a new piece of code, I want to go stuff it down in, and I have to see that the class loading has stalled so that I can see you didn't invalidate any of my assumptions. And the fingers go everywhere and on and on and on.
So if someone was on the committee for WebAssembly trying to standardize the API for their garbage collector, which I believe they're mostly done, but haven't actually fixed that standard yet, what should they go read to understand the pain that Java had and try to?
And there's pain there. I don't know there was a write-up. The Growl guys were more academic minded and you try to re-implement using in Java. They might have done something there. They might have a better write-up of an API for the JVM. I know there was an effort to go publicly, like official API, and never really went too far because it was just too ugly already. And no one was going to rewrite all the necessary pieces to go make you API compliant. What's Steve Blackburn's group? The MMTK? They tried very hard to make a decent API for their JVM, I would say J9 or whatever, for the garbage collection side, and they were doing GC research. So I think they nailed down probably a reasonable API for doing GCs. I don't know, Zalim, have you seen any of their stuff? I lost you. You have your video, but not your brain.
Do you mean in WebAssembly?
For the GC proposal that you're doing for WebAssembly, I'm saying that
there is no common API to access GC itself.
I'm proposing that they have done interesting research on what a GC API might look like, whether or not it applies to would apply to WebAssembly. It might be useful to know that exists. Memory Management Toolkit. Okay, MMTK. It came
there is some similar activity inside Wasm time. It's Wasm virtual machine, and right now they're working on implementing on garbage collector, and they trying to have some abstractions to have later to be able later to replace GC, to have different GCs, but it's just part of Wasm time, not in general, not part of WebAssembly. In my from my point of view, what Wasm time trying to do more or less similar to probably OpenJDK, like inside OpenJDK you can have different garbage collectors, you can switch them.
I'm believing there's want the goal to switch them, just thinking what the API here is. I got a different question for Wasm. Does Wasm do anything with concurrency, multiple threads, or is it all single-threaded thought?
Yeah, there's a thread proposal which added threading primitives like atomic for atomic operations. So there's proposal what is finished and provide such of primitives for linear memory. And the second part about GC structures, it's not finished. It's just started about half of a year ago. So for GC structures, we want to provide the same primitives, atomic primitives like atomic write, read, and so on. Aside of that, this new proposal trying to split this multi-threading world and one-thread worlds. So this proposal adds kind of modifiers. So your structures, you can mark your structures as like shareable. So shareable structures can reference to shareable, another shareable things. It could be structure or shareable function, shareable table, but you can't refer to non-shareable declarations from shareable ones. So we split these two worlds for safety. Firstly, to be able to verify what non-shareable things don't cross this boundary. Especially, it's super important for browsers where we have JavaScript, which not have these multi-threading capabilities. So we don't want to open this through WebAssembly.
So in the models that you're doing for concurrency, there's a notion of a thread that you can start and stop?
No, right now there's no such things inside WebAssembly. So to provide to start or stop threads. It's something what should be done on host side. Inside browsers, you have workers, so you need to use this API. Outside of browsers, it's different between different virtual machines. There's side activity in WASI, WebAssembly system interface. There's, I think I saw the separate proposal about providing APIs for starting, stopping, for manipulating with threads. WASI threads, I think.
So
core spec too, there's also some stack switching and coroutine proposals that to land.
Okay. Like the WebAssembly is expected to be reentrant.
That I think is the stack switching stuff.
Okay.
Yeah.
Well, if you're not reentrant and you have multiple threads, what are they doing on the WebAssembly? They're not sharing the same stack, are they?
They being individual modules?
No, individual threads. So the browser has decided to launch 5 threads to go call into this piece of WebAssembly. They're all calling into it. What's the model? They all have their own stack, yes?
Could you repeat?
You're talking about a thread and it's spawned from like the host side in JavaScript.
Oh, I asked about threads and he says, oh, the host has to provide a thread. Okay, so the host provided a thread. Thread says, Mr. WebAssembly, give me some service. Go run.
What I got from the link, it's much more of a memory spaces, space where objects can be shared between threads. But
yeah. You know, naming is hard. The proposals called threads or something like that, but actually it's about providing primitives, atomic operations, basically.
Or sharing objects between threads. So
yeah,
but then okay, so I've called into some WebAssembly from a browser to go do something, and then the browser internally is parallel, so he calls in the same WebAssembly with a new thread. What's the interaction model here? These 2 threads are running around the same piece of WebAssembly code. What's the interaction model? So you disallow, I can't call into WebAssembly while I'm running WebAssembly. You allow, but now there's just atomic operations to share at. They have private stacks, they don't. I'm trying to figure out what the model is.
Inside browsers, you have workers. So for workers, my main way to interact is sending messages, but there is some. So when you send messages, you serialize, deserialize things, but there is some special types what could be transferred between workers, and there is special type like shared array buffer. So you can have reference to the same shared array buffer in different workers inside browser and manipulate same piece of memory in different workers, basically in different threads.
You're talking about workers here who are outside the Wasm model, modifying memory that came from inside the Wasm model? I'm
yeah.
confused.
Yeah, this shared array buffer could be used as memory inside WebAssembly model and as linear memory. In WebAssembly from 1.0, you have basically memory, which is linear memory.
Right.
It's just bytes.
Right.
So before GC structs, you just have this piece of memory.
Right.
So if you use shared array buffer, you provide shared array buffer inside your Wasm model as memory. Inside your Wasm model, you also can use these atomic primitives to work with this memory, and it will be visible from other workers.
All right, so somebody's come up with some memory outside any particular Wasm module and is sharing it across multiple different Wasm modules as a
you can use the same shared array buffer as memory for different instances of WebAssembly in different workers, and that's way what we have right now for multi-threading inside browser, basically.
Both different WebAssemblies and JavaScript potentially could also have a handle into that buffer.
Yep.
Yeah.
I got to run to another meeting. Good to see you all. Thanks for having us.
Yep. Bye. All right.
Okay.
Yeah, there is something that just feels right about spelling alloc as new uint data array number.
Then maybe memory alloc, malloc, new uint 8 array. Yeah. But this is for Wasm, in C, next thing you do is you cast that to whatever type you want. Then it's C++, you said new and type. So I'm trying to figure out what you're getting at, Aaron.
I have a vague memory of if you want a shared buffer between Wasm and JavaScript, that it just had to be a uint data array.
No.
That you weren't passing around rich Java objects.
From point of view of WebAssembly, it's just memory. From JavaScript side, you have typed arrays what under hood have access to buffer. So you can take this buffer and construct any kind of view you want, actually. You can have different views, different type of views on the same buffer. Yeah, whatever bits you need, what you want. And there is another more generic view, data view, I think, which provide just APIs, all different APIs.
These views are read only or read write?
No, you can read write.
Okay.
Yeah, I'm wondering how security works.
That smells like
you feel
bubble.
like there's some fun games if I'm looking at a U8 array and you're looking at a U32 array and they're the same array.
Yeah, somebody can craft a specific set of bytes that can be interpreted not
so the
how it's
caller,
supposed to be.
JavaScript, it's his responsibility to understand what the Wasm's going to produce if he's reading a buffer. You got a shared buffer. Wasm's untrusted code from the interweb running. He has to
I think the key there is that the typed arrays, you can really mess with your data and do a lot of bit fiddling with typed array games, but you can't make a pointer.
Yeah.
The data that's in the typed arrays is not a pointer into somewhere else in memory ever. It's always a data value.
Yeah.
And I think the fact that you can't go between pointer and not pointer gives you a lot of safety. And going from float to int is just not where the safety problems tend to come from.
Primitives are fine, but objects, complex objects, like classes with fields.
For objects on top of linear memory, languages like C, C++ just work on top of bytes. So there is on WebAssembly level, inside linear memory, there is no information about objects. It's everything up to language which work with this piece of bytes.
Yeah.
So you will be responsible for serializing, deserializing potentially to this space. So
yeah, if your language work on top of linear memory, so your language compiler responsible for every work, for layouting things, for writing, reading, for allocating, deallocating. In comparison with GC proposal, we have structs, and you don't need to think about layouts, about allocating. You just describe your struct, and there is instructions to say like, I want to have new instance of this structure.
And that's outside the linear memory then.
Yeah, but they live in the heap. You don't control.
Because once you talk about something outside, the next language you need to understand how to interpret that, to convert it to an object, to an instance of something. So that can become problematic.
Well, serializer, deserializer, something.
Yeah.
Yeah. Okay. Welcome to Serialization Hell 101.
Yeah.
Right,
Fun
but
stuff.
it's still a sandboxed serialization hell. Like, if you compiled a bunch of C code to Wasm, you may have some kind of memory bug that allows parts of your Wasm code to read memory that it wasn't supposed to read in other parts of your Wasm code.
Hey, Zaleem, there's a bunch of links.
It's not going to read a different browser tab.
Let me interrupt for a second here. Zaleem, you're putting links in the chat, which is great. There's
I will copy them.
Google Docs. You're going to copy them? Okay.
Oh, okay. It's better to put to document.
Eventually, yeah. I don't know.
I will
People
do.
like
No
chat's
problem.
usually boring. And I don't know if people ever read all the chat, but they usually poke through the doc.
Okay.
No, I will put. Oh, okay. Good.
When are you?
So, are we done with Wasm or
Right.
something else?
Yeah, time for something else. Or it could be done early.
Well, I can ask a Kotlin question, but you know my questions about languages and compilers are never good.
Go ahead, Leo.
Okay, so I asked the same thing about the .NET developer that was here a couple months ago. So I tried Kotlin on the command line, and I think Hello World took like 3+ seconds to compile. Is my system messed up, or is that how it's supposed to be, or do you know why it's taking so long?
Spinning Rust, Lipo.
It's compiler is written in Java and Kotlin. It run in JVM, so first start of your JVM code start is not so fast usually. I think that's the main reason.
Yeah, it is legal.
And actually,
somebody this question without having access.
Most of users don't use CLI, so we more working on compiling from build tools like Gradle, Maven, and there we have compiler daemon, which after first start will live in your memory for some time, which allow to next compilations could be start faster. Compiler will be JVM will be able optimize classes better. Also, for build tools we provide incremental compilation, which also provide better compilation time.
Okay, yeah. So it just sounds like my use case isn't is not the use case that they optimized for. All right.
The Clojure community landed in a similar place of, if you are some editor that's doing a lot of compilation because it's highlighting things, leave a server running that you then send all your compiles to, because the time it takes to sort of bootstrap itself before it even reads your first token. I
think it's a common practice. I think it's common practice especially for compilers running inside JVM. Same things for Scala. I think I saw.
What about the flip side? If your project gets giant and has 1 million lines of code, is it roughly linear in the size of the code base that it takes to compile, or?
I don't know.
I mean, I'm happy with n log n also. N squared can get scary.
For Kotlin to not go to machine code, I would expect you should be something close to linear. I don't know if there's anything going on that requires a huge amount of time.
Probably something similar, something close.
Yes, I don't know.
What is the blessed build tool at Kotlin?
I mean, Rust is definitely not linear as the size of your project grows.
Is it? But it's going through LLVM, right? There's a bunch of backend algorithms get expensive fast. So if you've screwed up register allocation, or you screwed up whatever bit vector / data flow analysis thing, you can go quadratic in a hurry. But front end stuff, in my usual experience, is it's all, I throw things in a hash table and I parse and I stitch things together and I'm done. And that's kind of all like linear. But
Yeah, it's
Well,
definitely
we
the
have inference, which
The
try
types
to
can be
type
complicated.
inference. Yeah, okay.
yeah.
Rust also does borrow checking relatively early on.
Why would
borrow-
borrow checking algorithm, is the borrow checking algorithm not linear? Is it like quadratic or exponential or something weird?
I think borrow checking is quite cheap. I think what costs more time is trait coherence checking, and some like trait resolutions, things stuff like that.
Yeah. I assume trait resolution should be quite complex, so it can be quite complicated.
Don't know enough about Rust traits.
I don't remember the details exactly, but Cliff, do you remember me talking about my array test?
Your how fast you can go compile?
Yeah, the 3
Yeah,
million array test.
Yeah, it was kind of lame because you're doing the same code a billion times over. And
Yeah, it's measured.
that.
It's measure end to end upper bound, like how
Yeah, but
the upper bound of compile time.
But the kind of things you compiled were extremely trivial and totally identical. And I think that was that was the flaw I had with your benchmarking strategy.
Yeah, it's not meant to be realistic. That test,
right?
I ran that test in Rust. For the 1 second that it took mine, it took Rust 3 minutes. And when I benchmarked it, they had most of the time in the type, like the type system. I don't think it had anything to do with borrow checking. It was just typing the type.
Comparing, I have some problems with comparing that that design space, because I've seen a code written in Scala and in Java, and the code written in style Scala code written in Java style, and I don't think they're actually fair to compare them in that way, because they're doing a bunch of things that are let's say they are on the back of their heads, so they always keep in mind while they're compiling, and this complexity pays off up front, and that would get hugely better compile times at the expense of the compiling simple stuff more costly.
Right. That's a common thing. I pre-cooked a bunch of stuff up because I have to track in case. And if you're only doing array loads and stores. And
so a really amazing design would be to track that piecemeal to exactly prepare what you need, but that just won't happen, at least in my opinion.
I claim there's like a fuzzer thing here that would work for you, Levo. Go generate a big wad of Boolean code with a fuzzer and change the fuzzer's output to target Java and get a Java C and C code from somebody else's C code that's not Boolean, and then do compile speed checks. I think that would be a better game than doing just arrays.
I took Matt's suggestion and went to Rosetta code. I think it's Rosetta code, but
you had to write all those examples yourself, right?
No. So what I did was for every example I found, it's not written by me, so it's completely fair. I took some Go, some C++, and I don't remember if I did it for anything else. And I wrote a Python script that basically duplicated the functions. I think most of the code was up here. So I duplicated the function
to Boolean.
No, I didn't measure in Boolean. I just duplicated the like the function. I just like slapped an integer at the end of each function.
Oh, you just made copies of the function bodies.
Yeah. So I used a script to do it.
Yeah, right.
And I had like 100,000 or 10,000.
Right, you're trying to get big enough to measure. Fine.
Yeah. So I did that for. I know I definitely did that for Clang and Go. Clang single-threaded was able to outperform Go, which is multi-threaded. So I did that because Yasser was trying to argue with me. And so I thought that was a pretty fair example. Maybe I should do something with that and Boolean. I should actually write the examples in Boolean and then repeat the same thing. But
that's a better test than what happened before, because you get more variety. in the
It's
function
very
logic.
strange that the type system took longer than LLVM. Like, I did not understand that.
Oh, I do. I've been screwing with type systems for the last 2-3 years, so I can understand why.
My type systems are so fast, but yeah,
But
I
your
have
type
no
system is
idea.
so simple.
Yeah.
Yes.
Yeah, and if I look at what I do in the simple project, its type system is simple. And there's no typing issues. It's all super fast. It's great. As soon as you pull out something involving Hindley-Milner and or layers upon layers of interpretation before you can get to Hindley-Milner, it can get ugly fast.
The
You
best part
have a very
about
simple type system, sir.
the best part about my simple type system, it still managed to do static bounds on, or static array bounds checking.
Right. Yeah, you have some
Okay.
interesting design choices. I wouldn't have gone there, but it's an interesting design choice. But for instance, you're not going to support a map reduce style of coding where I want to map over a collection and the map takes an arbitrary function.
I hope to do that one day, but
Okay,
that's
well,
not
shows how you do it with a strongly typed system. Because as soon as I said that, almost surely you're stuck doing Hindley-Milner. And Hindley-Milner can be fast, but you can also screw it up and go slow. And then if they go into something past Hindley-Milner, you get dependent types or F# or whatever the hell, now you can get ugly.
At least my experience with Rust was not that it got bad fast, but that it got bad slowly. When we had 100 dependencies, our build times were fine. And when we had 1,000 dependencies, our build times were not 10 times what they were with 100, but 100 times what they were when we had 100.
There is another thing there, by the way. I hit this before, benchmarking. When your data structure is of size X and X fits into L1, and you make it 10 times bigger, then you think
Yeah, and
it's 10
suddenly
times
you're
slower.
in L3.
Yeah, and it's an L3, and it's 100 times slower. Yes. But then that jump is only once. So the jump from 100 to 1,000 was 100-fold, but the jump from 1,000 to 10,000 might pick up the 10 that you get, plus maybe at most 10 to go to L3 to memory or something.
Yeah.
And
The
then
other thing that
jump from
C2
10,000
is very good at is doing pruning as it goes.
Yeah.
So if I'm building up some intermediate object, and I start with 10 gigs of code, and I expand to a terabyte of intermediate whatever, and then I come back to 10 gigs of code, that's going to be a lot more expensive than if I have 10 gigs of code and I keep adding a K and taking a K away and adding a K and taking a K away and adding.
Totally, yeah.
That's a
One of the
lot.
problems that Rust has is there's a lot of places where you have some trait, abstract base class. And what happens in Java with the abstract base class is you just sort of say, here's some spot I'm going to do a, jump, load register, call register, whatever.
Right.
Load, jump register, whatever.
Yeah, it's 3 loads and a jump register. Yeah.
In Rust, it says, oh, let me look through every single static type that is in this compile right now in any module that I'm compiling simultaneously to check, does it match this trait?
Boy.
And the answer for almost all of them is no.
No. Right. Then they go quadratic really quick. As a minimum, it's quadratic.
What you want to do is just sort of put some placeholder here that's like, and all the traits that match. Well, and eventually get to a point where you do some data flow analysis and say, look, if this particular struct can never actually reach this spot because there is no data flow between it, I don't need to check whether this struct matches this trait or not. And I don't need to generate code because it can never arrive here anyway.
But you can always introduce implementation for in any module. So how?
I'm surprised there's like no sort of boundary saying like this has no visibility into that, because it makes no sense to check everything all the time.
Right. And part of that is you end up recompiling a bunch of stuff you didn't need to recompile because you're like, well, maybe one of the traits in this other package can interact with the thing that you just made because you made a change to one of your structs. And it's like, right, but if I never actually pass that struct into that package, don't recompile that package because it's not affected by this struct because I never passed it into that package.
FYI, for whoever's listening, My array test has no traits. I have no idea why the type system took 3 minutes. And Aaron, when you said 100 dependencies, I got nervous. I didn't expect you to say 1,000 afterwards.
Aaron works on bigger projects than you do.
Livo, do you think that anyone using bowling will implement all these modules? He will not be reusing some kind of modules, some kind of functionality that's already out there. So to ease.
I don't even use libc.
Okay,
Yeah,
fine. You don't use libc, but someone that will use bowling.
Right. If you're doing a low level bring up small chip thing and you want to have a minimal footprint to get it started, that kind of attitude makes sense. If you're trying to write the next Twitter thing, that's not where you're going to go.
See, I'm pro
Livo. No dependencies.
I'm pro Livo that minimal dependencies is always good to have, because you have fewer things to worry about. But reusing functionality is fundamental for every programming language, and you have to have it.
I actually think I would even disagree with Cliff about like this small embedded system, like or maybe it doesn't have to be small, but just generally I think like this type of reusability can actually really work well in systems programming. Like if you the thing is, if you have a memory state language and you have decent ways of building abstractions and nice interfaces, then like actually writing embedded system and low-level stuff becomes very pleasant, because like you don't want to implement everything from scratch. And I mean, doing it in C is really a pain, because a lot of times you can't trust the abstractions. I mean, if someone does a B-tree implementation, it's very hard to like use it correctly just the way the person intended. In like something like Rust, you have more safeguards. So and I don't know, like I do envision something.
I don't want to write concurrent hash map. I want to import concurrent hash map.
Yeah, I mean, like in my case, actually, I do envision for my language at some point that the standard library actually contains like all kinds of drivers or like platform support, firmware, BIOS, all these things to actually write system software in a nice way. I think that would be cool. And basically, kind of like a standard library for like how we write it for normal languages, but for systems people. So yeah. It's just like I can't take it from like I can't rip it off from current projects because all of it is GPL code. So I can't compile everything into nice static binary. And so that would be my issue. But I'm just saying that this
GPL is stopping you from doing this?
Well,
I can't. No one's got this from other places?
Well, I think you got to make it dynamic.
Yeah, I don't want dynamic linking. I mean, I don't want to throw away all the compiler optimization opportunities. Yeah,
you're doing a kernel, you want a big old static mono kernel.
Yeah.
You can't get parts that aren't GPL'd that you would expect.
Right.
So tell me that there's an expectation of system programmers that are going to get concurrent hash map or whatever, not GPL. They're going to just plug and play. They would expect to, and they can't, because there is no not GPL one.
Yeah, I think for data structures that will be easy to find, like or easy to write, implement yourself. It's just for many of the drivers that come from the vendors themselves. Like it's I can't just copy the code, but if I want to implement it myself, I need to reverse engineer things. It's very difficult. Like basically all of the
driver code from the manufacturer, they're not just letting you have it so you can plug their hard drive into your
You can have the GPL license for free, or you can pay for a commercial license if you would like to use
the
it.
Linux has a driver, one open source implementation and one closed source implementation as a binary. So you have to trust it. You cannot, you just install it. So
Adrian, is there a problem with having the source open? So you can, I think you can statically link things if you also provide the source for them to recompile. I think that's how it goes.
Well, the GPL is viral, so if you link static.
So your source isn't open.
Sorry.
Your code is an open source.
It is open. Okay. So I was talking about my standard library, And obviously, people who would use my language to build their own operating systems would want to use my standard library to compile code. And like some of them probably would like their code not to be infected by GPL.
Oh, I see.
Yeah.
Yeah.
I agree with Adrian. You should not put something into the standard library of a programming language unless it's really open.
Yeah,
You
really.
can ask for
but
it, but it cannot be part of the standard library. So
yeah, exactly. I mean, that's the challenge because most of this type of code is provided for free under the GPL in most projects. So yeah, but my main point was actually about the reusability. Like I think at the systems level, it's kind of underutilized, like partly due to history, partly due to other things. On the application level, like all the front-end people, like JavaScript folks have figured this out quite well, how to like, yeah, make things, like reuse things to be productive. So I think it can be a huge boon. Yeah,
I really do think
level.
JavaScript guys went overboard with this, but
I mean,
Yeah,
I think
I was
they
thinking
do
the
focus
same.
on UX a lot. That's what I mean. Like, I guess maybe the Ruby people are a better
Oh,
example to
yeah.
look to.
Okay.
Right,
I
but
waited
both
too long.
JavaScript and Ruby and Java solved this problem by being very dynamic about the way you call things. New things can show up that can interact with your code. Rust is trying to solve this same, you can have lots of tiny libraries that have like a data structure in them and
But
thousands of dependencies.
But the
But they're
problem with
also
Rust,
trying to not have any runtime linking or loading or
so
non-static calls.
they do not have generic types in their compiled libraries. So that's
And if you replace every abstract base class with a generic type specialization, that gets expensive. You're
yep.
gonna run up your compile time.
So I waited too long to say this, but Cliff, my Bolden is not supposed to like replace low-level languages. It's supposed to be so I don't have to work with C# or Java or Go anymore.
Well, there you
So
go.
ideally, I would just write all the complicated data structures and like hash maps and whatever in the standard library, and then people just use the standard library.
Right.
And then there's not going to be any unsafe things because you would either have to do FFI, which is like always unsafe, or you just stick with the standard library.
Right.
Yeah.
You got to write a hash table first.
You ever
I
heard
wrote a
Kernighan
hash
talking
table.
about the awk programming language?
I'm sorry.
He's like, we started with associative arrays, and we told people if you can find a program that can't be written with associative array, then we'll add a new data structure. And for decades, people would show up and say, here's a program that you can't write using dictionaries as the data structure. And they would show them how to write it using dictionaries as the data structure.
Wait, the awk developers like would tell people how to write code, basically?
Yeah, people come to them and be like, I need you to add this
Flexible.
other data structures. I need arrays in awk. You can't have me do it using only the dictionary.
Right.
And they'd be like, you don't need arrays. You need a dictionary from integer to your thing.
Right, exactly. And, you know, the only thing that would change there is the efficiency, which could be pretty big, but as long as you're not trying to awk, you know, gigabytes and terabytes, burn the efficiency, hack, and go to town. It's all good.
I'm super curious. What is the largest data set that's being processed with awk today?
Which one is?
I am super curious who has the largest data set being processed with awk today.
Right. Yeah, I don't know.
I don't think anyone would want to admit it.
No, they probably would. It's just like, it's a tool. I've certainly used awk on gigabyte-sized data sets, but not anything larger. And it was fine. And I had no worry. You know, I needed something quick and easy. And then the fact that it ran for 10 minutes didn't matter because it would take me 10 minutes to write a piece of code that would do that in C or Java. So it was just faster to slap it out in awk and wait my 10 minutes than it was to try to, you know, write a faster version in a harder to write language.
What was the billion row challenge? I bet you could write that in awk really elegantly.
Oh yeah, I'm sure.
Wouldn't be super fast, but it would be super readable.
It might be faster than the default Java version. Did you see what they did for the default Java version? Here is a standard good way to do it. Streams. They use streaming. Go stream this billion row thing through and break it up with, you know, split whatever, and then hash table the peoples out and add the numbers. Okay, fine. And it was done in, 10, 20, 30 lines of code. Well, I could do that in awk in 10, 20, 30 lines of code too. But I bet you'd be faster. Wow. Brutal. That first implementation is like, this cannot be what you intended to be the default way to do this. And the difference between the default version and the fast versions was about 100 to 1. It was hugely different.
I have one question. So maybe has someone done something like this? Basically, I'm trying to profile a program right now, like figure out how much time a certain thing takes. And so obviously one approach is sampling-based profilers or other things like that. But there's one thing, and that is that like some projects rely on number of instructions as a performance metric because it doesn't have so much variance. So it's good for like maybe it can be good for comparing like relative performances between two versions or maybe regressions or something. At least that's what some projects do. And so I'm wondering, do you guys know of any infrastructure or like way of instrumenting the frequency with which a certain function has been called, and maybe like or actually the percentage of instructions that a certain function occupies or takes from the total, like 2% of the total instructions belong to this function. Like, is there a way to figure out this information?
So two different things. If you're counting the number of times a function gets called, put a counter.
That's not what I want. Yeah, that's not what I want. I want to know the number of instructions that like out of the total instruction count that belong to this function.
I think perf interactive mode shows you percentages of instructions. How often?
Yeah, I was gonna say, does the just GNU perf?
Yeah.
Okay, perf does it.
I believe interactive mode shows you percentage of instructions. So.
But they also it would have to also like count all of the basic blocks that belong to the function, right?
No.
It's sampling.
Sampling.
Sampling
on entry and on exit. So on entry, you're at this time. On exit, you're at that time, or the time is maybe nano, or the RTC register, TSC register, and diff says, okay, I counted in, counted out, counted in, counted out. There's sampling as well. I don't know if you guys are. Is gperf doing sampling, or is he doing? I've certainly used tools that just said time in function from read the TSC register and diff.
Perf is definitely a sampling.
Sampling, yeah.
Yeah, and I know there's some kind of counted QE move that runs your program on a virtual machine and counts all the instructions.
Oh, okay, that's cool. All right, that's useful.
You want time, or you want count of instructions?
I really want a count of instructions. I don't care about time. So that's why sampling like wouldn't be necessary. But I guess it's something like counted QEMU. That sounds interesting. I can look into that.
I know, like Loris and Ball style, but this is you have to. I don't know who does that. You have to implement it yourself. There's a way to get fast counts, including counts of instructions. But that I'm talking about a high theory thing. You'd have to go implement. I know it's been implemented in the past, but I don't know who does that now.
I also know there's a way to do it with Microsoft's Hyper-V and Visual Studio for Windows apps, but I've never done that either.
The virtual boxes will actually count instructions. Okay, I hadn't seen that.
It's useful. Okay, cool.
I mean, it's slow.
Yeah, right.
Not running in real time when you do that.
Yeah. Loris Ball counters will not be slow. They'll be fast, but you have to do somebody has to profile, have to run your app in profiling mode. Saying, I want you to profile just this one function.
The reason I find it interesting is that, I mean, first of all, for instance, LLVM, I think that several LLVM folks rely on number of instructions, like the count, as a performance metric that they track or take quite serious. Like you can debate if it's a good one or not, but certainly some projects do it. And the nice thing is
cache missing and time with.
Of course, yeah. Like it completely disregards memory. Like also it confuses SIMD and like non-SIMD ops, which completely, I fully agree. It's just it is definitely a flawed metric. But if you care about it, then technically you can instrument all instructions of a particular function, and then you can actually calculate very precisely an upper limit of improvement. I think that's very useful because I feel like sometimes the performance work done on some compilers is guided by maybe some kind of gut feeling or quite inaccurate samples or like poor benchmarks.
Right.
But
It happens. But why do you get a sharp upper bound?
Because the thing is, if the upper bound shows you can reduce total instruction count by at most 0.1%, let's say, then that should tell you, oh wait, okay, like even if the metric is a bit flawed, there's no way I'm going to have like a
but there could be a version that says I'm going to double the count of instructions and my program will run twice as fast with double the count, because I've unrolled and then constant folded and a bunch of other fun scheduling things, and I got my prefetches, blah, 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 whatever, and suddenly I'm twice as fast. So this is the flaw with the I'm counting instructions metric, but I'm gonna claim it's a flaw in thinking that there's an upper bound of performance improvement based on how many instructions I can subtract. But sometimes it's faster to add instructions than to subtract them, and is that where you really want to go? Right?
If you count instructions, then the semantics of the problem is gone. So you can really, you're guessing. So you really cannot.
Well, it's not that bad to have extra instructions in a mem copy.
Not that bad to have extra instructions all over the map on an x86. It's fucking 4 wide issue. You can't fill those 4 slots all the time. You got a ton of extra issue slots. You got to do something useful with your extra ops, but you know,
for mem copy in specific, when everything's aligned, it goes much faster. At least from what the little I've seen.
But why wouldn't subtracting the instructions of a particular function be a good upper bound for what performance improvements a quicker version of this function can bring? Like
I'm saying if you subtract instructions, it probably runs faster, and you'll reach a point where you can't subtract anymore. But there may be another place where you could add instructions and go faster.
That's true. No, yeah, absolutely. Yeah, I'm just saying, like, if you for some reason want, like, I mean, you're looking at like a particular function you want to optimize.
Right.
I mean, and like if the total number of instructions that you spend during the whole execution on this is very, very, very small, then probably it's not worth optimizing. But people rarely look at this data.
Oh, no. It's like I say, okay, if the total count of instructions across all executions, I was thinking different thing. Yeah. If I have a tiny function that's called a billion times and I do tiny -1 times a billion, I subtracted a billion and I'm happy. But you said it right. I got it wrong.
Right. Yeah, but I think like looking at it this way is like few people like have. The thing is also counting how oftentimes a function has been called is not good enough, I think, because a function, like for instance, a hash function can have many branches and all with different code paths that have different specializations. So like the number of times a hash function has been called doesn't tell you how many instructions have executed that belong to this. So maybe only a particular code path gets exercised, and then so you don't get very accurate.
Here's an easy way to run faster and use more instructions to run faster. Suppose I'm using a garbage collected language and I do a lot of news in my hot inner loops. All the news are guaranteed hard cache misses. I swap them with object pooling. The object pooling tracking means I have to, the new happens in the same spot, but the free is for free in the garbage collected, except that's not. And the free on the the malloc free version, I had to think about put a malloc in. I ran some instructions to recycle the pool, but I quit getting cache misses. So suddenly I went from main memory bandwidth speeds to L1 cache speeds, and I get 10x, 100x faster. But I added instructions, ran more. I didn't just do bump pointer and carry on. I had to say bump pointer here, but then unbump pointer there, and I added more instructions, but I'm twice as fast. So just.
Yeah, for sure. I mean that's the best way. I mean, obviously the best way to do it is you check wall time on a system that is reliable and has like a proper benchmark rig without hardware failures or quirks.
That's my usual good answer for That is, you have to have a dedicated machine that runs benchmarks regularly, that is only being used for running benchmarks, and and then you get reliable timing numbers and you can compare them. Okay, fine.
Oh yeah, we tried running benchmarks on Google Cloud Spot instances that drop you on a different physical box every time you start it.
Yeah. Oh yeah.
With no code changes, we would see 20% swings in the performance just based on where we landed.
Wow.
Okay.
What the other load on the box was.
Right.
Like,
what your neighbors were doing, your noisy neighbors were doing. Yes.
Whether a data center operator is screaming at your rig or shouting at the disks.
Right. That's the other thing. We're running benchmarks, so we totally trashed whoever else was on that CPU also.
Right. Yeah. We had a project a long time ago in my early jobs where we needed benchmarking for compiler performance improvements, and we had a dedicated machine, but it was on the public network inside the corporate network. And people saw this big empty machine they wanted to jump in. And so we had to go, somebody annotated the login, log out of some top thing that they annotated something that was very fundamental that you couldn't dodge, and you showed up in the process list. And this ran constantly all the time. We just paid it as part of our benchmark overhead. And if somebody else came in, it shot them down with, kill -9, sent them hate mail to the user, whoever was, authority, whatever, and then told the benchmark, try again. And we had a lot of screaming and yelling of people. It was amazing. There's a nice machine we paid for from the compiler group sitting on the corporate network. A bunch of folks would pile in and they get all screaming mad. And we were like, you just trashed our work, dude. Why are you mad at us?
You couldn't just limit the user list?
There was some rule. It went through IT. IT said, here's this new machine, and it's for the compiler teams, whatever. And, but people would find it. They would log in. And then we had trash numbers. We were trying to sort out things. This is when we discovered the impact of iCache layout. 20%. Just like you said, we got 20% in performance improvement by sorting the link line. We take a big benchmark, and there was a link line, had all the things from the make file, and you ran it, and you linked, and you ran. Well, if you'd sort the link line, it got 20% faster. It's like, what the hell does that mean? Well, that was iCache layout. So that was one of the bugs. The other bugs were, people logging into your benchmark machine and fucking with you and whatever. Like there are a lot of things sorting out.
Sorting as what?
So sorting, like the link line was the make variable that had all your .os. Would just produce a link line that said LD, some flags, 200 .os. Okay, like you sort the 200 .os. So AAB.O comes ahead of, BCD.O comes ahead of XXX.O.
Right. The point isn't that sorting helps. The point is that shuffling makes a difference.
Yes, exactly. The point is that shuffling the order mattered. We all thought it did not matter. So I would come through and say, I have these 200 things. I'm going to binary search them to run them fast or slow mode, run them -02 or not, see which one has a relative cost performance improvement. And I was trying to burn it down to this. And I got this one guy, and then it was like, if I put him at the head of the link line or at the end of the link line, it made this big difference. But wait, it had a .o versus -g. Why? I mean, what the hell is that? Not bigger difference? No, took a while to figure that out. Fine, and then that turned into iCache.
Although to this day, I don't know anyone's build process that shuffles the binary around.
There are plenty of
and just like makes 16 versions of the binary and then benchmarks them all, and then you only publish the one that wins.
Somebody find stabilizer for me as a link. This is from Emery Berger. He totally does.
That works, I think, on Clang 3 or 6 or something like that.
Stabilizer?
And I could not get it to work on like the up-to-date Clang.
Fairly generic.
There's an exponential number of layouts, but if I just make 20 of them and take the fastest one, I've probably got a pretty good one as far as the population goes.
Right, he's very good with his stats, so he knows how many. The prediction in Google had it, and then they lost it when I mistyped, and I had to backspace and go forward again. Stabilizer, here we go. I'll throw the link in. Wow, this is a day for long. Somebody beat me to it. Oh, you got the other version of the link. I got the Emery Berger's direct link. Fine. Yeah, but that's exactly what he does. He says, let's get some reliable performance numbers. If you claim the order doesn't matter, we're going to shuffle them all. Shuffles the heap, shuffles the iCache, shuffles the memory layout, shuffles this, that. Run, shuffle, run, shuffle, run, shuffle, run. Statistically, boom. The common answer comes out is whatever numbers you're using before varied from their peak performance by 2 or 3%. And we can show that statistically speaking, that was a non-measurable difference. That was not a significant difference. You thought you got a 3%, now you got random noise. That was a big one.
That's interesting. And Matt posted recently a link on the Discord about Bolt, which is this binary layout optimizer, I think, like post-link optimization of the Linux kernel. And that's yet another interesting thing.
Yeah. Yeah.
There's a bunch of research into like rats. And if you give them a lever that gives them a pellet every time, they're fine with that. If you give them a lever that gives them a pellet every 5th time, they just sort of accept, okay, I have to hit the lever 5 times before it gives me a pellet. If you give them one that has a 1 in 5 chance of getting them a pellet, but there's no pattern to it whatsoever, they just keep pulling that lever all day because the randomness drives them crazy, and they gain weight because they have an unpredictable food source, and it's like really bad for their anatomy.
Really?
And then I do performance benchmarking, and I think about that.
I will do too.
Okay. All right, everyone, all us rats in our mazes here, are we all ready to press our pellet buttons?
This is why I look at the assembly.
Yeah, because the assembly will tell you what's better. Maybe.
But it's crazy. You
feel
change
bad.
things and you're just like, is this better? Maybe. Is this better? Maybe. Is this better? Maybe. You're just
Maybe.
living with this totally probabilistic reward function.
Yes, maybe.
I am
got a good
convinced
answer.
with
I'm gonna
programmers that if you look at a programmer's year, their best day was more productive than their worst month. Like, that's crazy to me.
Well, that's the manager's version of the same pellet pushing button. Some of these programmers do really good shit some of the time. Some of the time they're trash for months on end. What do I do?
Right. What do you do with an employee who
gets
nothing done for 4 months and then saves you $1 million in 3 days?
Right. Now what do you do? Yes. Well, I got to pay him salary, so $1 million covers his salary for 5-10 years, something, and then maybe okay.
You have to take a bet. You have to take a bet for a developer. So.
All right, we wandered far off track, and I'm ready to go do other things. So, we got any other last questions or comments here?
I get one comment. It's I realized that I guess I'm closer to a rat than I expected, because I do have this one benchmark. So I like every time I make a change to my compiler, I have a benchmark that runs through it, compiles a test program 10 times and averages it. But I keep clicking the test button, like the benchmark button, every time, even though I already have a loop counter there. I already like tested 10 times and average it. And no matter how high the number will be, I will always rerun the same benchmark multiple times.
By the way, the correct answer should be 30, not 10.
But if you rerun, doesn't the CPU learn your branches, and it slowly improves the program because
you need the standard deviation. Because
but if you run it again and again, go ahead.
You need the standard deviation. Because you need to look and see that it's actually stabilized at a number, or it's got a wide standard deviation, then you are like really fucked. Whereas if what you're saying is true, Theodore, which it is, it locks in at a particular point after a while, the standard deviation will get pretty narrow.
There are charts that the performance will improve slowly. The time will get slowly better because the CPU will learn all the branches, all the things.
Yeah, you didn't flush the CPU's internal branch prediction.
You have to run something else and come back to it later and find it's terrible. And
that's fair. Yeah.
Adrian, did you?
That was a painful comment. I just realized I have a whole bunch of benchmarks that output the mean, but not the standard deviation.
No,
so I don't
you bad
know whether they're good or not.
And then you want
I
to look
like
at it
use-
and see that
I
it's
like using minimum time. Adrian, have you tried using a NanoBench? Like I remember you asking about that earlier.
Well, NanoBench requires disabling secure boot, and on my
No, not
virtual
that
machine.
one. The other one that's more simple.
Ah, I guess not.
I threw a
I
link
think
on
it really
the
not.
Google Doc.
I mean, I just do like two like RDTSC, just compare two timestamps, and that's it. I think that's most what I need.
This one does something like that, but more advanced. I looked at the code once, I think, but I used that for a couple of benchmarks, and then it ended up being pretty good. So you should give it a try. But just check out the link in the Google Doc.
Yeah, it's interesting. I think I have so far I have not even gotten around to optimizing my compiler yet. Like for now, I've tried to be just smarter around choosing data structures. So like if I can, I avoid trees or indirections. I just use like just a bunch of arrays as much as possible. Yeah, and then like seems to work out quite well already. Like yeah, but at some point I'll start roughly like more rigorously profiling things, and then yeah, that's already why like one example of like why I asked about this.
You heard the story about the grad student who discovered that his benchmark changed by 20%.
Yes,
changed his name.
That was part of that was in the stabilizer paper, I think.
Yeah,
that's wild. That's
yeah. Okay,
that's pretty terrifying.
That's insane. I don't know how the hardware would even be affected by 20%.
Oh, the answer was easy. His environment variable
and stuff.
His environment variable changed from the name of his prof. So prof would run the program, get one number, he'd run the program, get another number. The environment variable was different by the size of their names, and it shoved the hot loop across a page boundary, a hardware TLB page boundary, and the x86 of that error quit prefetching across the page boundary in the hot loop.
Oh, yeah, I didn't know TLBs stop prefetching.
It's a full employment job for profiling engineers. I just gave Aaron some work to do.
Yeah, I think I'm gonna also do that. It's probably silly to ignore it. It's just I always forget how to calculate it.
No, it's easy, and every time I now do long time I'd always do standard deviation.
But what's your opinion? What's your opinion on the minimum time? Like, I think there's also a case to be made for that.
No, it kind of depends on what your goal is. If your goal is what the user experience is, the first run, all caches miss cold run is the user experience. So you don't toss it. If your goal is I'm steady high throughput thing, then you really want standard deviation over the mean. And you don't do anything like catch the min. The min is such an outlier. Don't take the min. There's a lot of good statistical evidence that says people who do things like take the min or the bottom three or you just run more. You look at your standard deviation distribution, your Gaussian curve, and you just run more, and you get the min, you get shoved further and further out the standard deviation, and your number gets more and more unrealistic. You don't want to do the min.
Makes sense. By the way, there is also probably I'll post it in Discord at some point. Okay, because I can't find it now. But I remember there was a person implementing sort benchmarks in Rust, and they had several implementations for thrashing caches before the benchmark. It was quite both I and D cache, so it's quite useful like to look at this kind of things.
You know, if your benchmark does lots and lots of sorting of things for whatever reason, because that's what your real life does, live with the data coming around again. If you're sorting occasionally and you want to make a generic sort algorithm for lots of people, yeah, you probably want to flush the caches every time.
Yeah. By the way, but that's one thing, like one argument that will make would make things depressing. If I really only care about the user, like if you're arguing from the perspective of in the cold case where things are not loaded in caches and stuff, that's what the user experience will be. Well, like if the program is not in the page cache, it has to be loaded from the disk, well, then my compilation time will always be slow, no matter how well I engineer my compiler. So it's a bit of a depressing.
It's a different, right. So I have had people who would just split those and report them separately. I ran my benchmark 30 times with cold caches, and 30 times with hot caches, and I report them separately.
That's that's even better. I think that's really good. Yeah.
Yeah. Like when I'm in my development cycle mode, I don't have a running Java C or whatever, but it's all hot in the OS caches. So I just hit my Emacs button that says go again, and it's instant. It's all quick because it's all hot. When I start from, Windows has rebooted me, thank you very nothing, and I have to go to everything up, and it takes forever to get IntelliJ to boot up and to load everything, and IntelliJ just fire up the thing and run the first thing, whatever. It's all super slow. And I just, grind. Fine. That's the experience.
Awesome. Thanks.
Yeah. All right. Are we done? Oh, here we go. Refined input, degraded output. Oh, interesting. All right. Yes. Matt put a
It's a fun example of unexpected things that can happen in the compiler when you add more information. Say you implement analysis path that is better and knows something more about the ranges of the values of integers, the optimizations can get worse. So you can get this kind of monotonicity, and the paper basically has a systematic way of finding inconsistent optimizations like this. That's kind of fun because you would think you would make something better by adding better analysis or giving more information to the compiler, and it actually gets worse in the optimization.
I lived in C2 for so long, and there the profile data does change run to run because it's all statistically random, done random sampling. And so C2 would make different inlining decisions all the time. Some of them were better, some of them were worse. Some of them were reliable of a set of patterns, and you could go run this benchmark, and 30% of the time you get this inlining pattern, and it runs with this number, and 40% has that inlining pattern, it's a different number, and there's it's like a compile plan built by C2 based on random profiling data.
And this one is this is kind of interesting because the way they found it, there is this way to inject information to the Clang NLV and GC compiler called build unreachable. So you can say, for example, if A is not equal to 7, build unreachable. So that basically tells the compiler that A has to be equal to 7. And they collected those informations practically doing something similar to what you are doing in C2, in that they first run the program and record all of the variable range information that is correct and is going to be then correct. Then they insert those built-in unreachables with this exact recorded information that is going to be correct. And then they optimize programs using that, and then it actually gets worse. So even though it's a perfect exact profile that is never going to be invalidated, there's no randomness or anything, it still makes things worse.
My favorite example of a better analysis making things worse was in the early days of Google MapReduce. It gets some big problem, it divides it into chunks, it then does a shuffle of all the pieces and then does the second part. And they did some prediction things that turned out made their ability to split work much more effective. So now, as they were dividing the pages, they got less of the effects of some websites are really big and some websites are really small. And suddenly the work was divided much more evenly, and the compute took 70, 60% of the time that the compute was taking before, because you didn't have all these long tails. But the entire MapReduce got slower because the network was entirely idle, and then everyone was fighting over the network during the shuffle, and then the network was entirely idle, and then everyone was fighting over the network for the shuffle. Gotcha. And because their work splitting algorithm had gotten so much better, performance went down, and they then had to deliberately stagger the work so that they weren't all doing CPU at the same time, and then all doing network at the same time, and then all doing CPU at the same time, and then all doing network.
The network failed faster than the CPUs did. They can't context switch the network as fast. Yeah.
And they were like, oh, we didn't realize we were relying on the fact that we were bad at predicting to stagger things. Once we got good at predicting, that was like, oh, now we actually have to stagger things intentionally.
All right. Now I really gotta go.
All right.
Thank you all.
All right.
See you.
Bye.
Have a good weekend.